Fractions. Addition. Adding fractions. So the first thing we're going to do is make sure the fractions have the same denominator, which means the number on the bottom. If no, then we'll have to get fractions to the same fractions. Addition. Adding fractions. So the first thing we're going to do is we're going to make sure the fractions have the same denominator before adding. If they are not the same, then we'll have to get the fractions to have the same denominator. And once they have the same denominator, then we can add the numerators, or the top numbers, together, and then we're going to keep the denominator. And then lastly, we're going to reduce the fraction to lowest terms if possible. So for instance, what this really means is if we had a pizza where one was cut into 4s, and then the other one was cut into 8s. So say you had 5/8 of a pizza left, and then say you have 1/4 of a pizza left. Well, if you wanted to find out the total of pizza left over the two pizzas, we couldn't really just add these together because this denominator is not the same. One's an 1/8 and one's cut into 4s. So what we'd have to do is get both of these into the same parts to be the same denominator, and then we could add them together. And so for this one, all we would have to do is cut this pizza into 8s, so we would make the common denominator 8s, and then we would add, if we did 8s, as we can probably just see, is then we would have 2 8s plus 5 8s, and then we would just add the top numbers together to give us 7, and then we could just keep the denominator because it's still out of 8 parts of a whole pizza. So 7/8 of the pizza would be remaining of the two pizzas. So that's how we can kind of see it visually. But let's go over some examples. So example 1. Add the following. We have 1/8 plus 2 8s. So notice on this one, we have a common denominator. So we don't have to do anything. So we can just go ahead and rewrite this. So what we do is we're going to go ahead and add our numerators together. So 1 plus 2. So that's 3. And then we're going to keep our denominator. So it's 8. So we have 3 8s as our final answer. Now let's look at another example. Example 2. On one winter day, there was 2/3 inches of snow that fell in the morning and an additional 1/6 inches in the afternoon. What is the total snow accumulation? We're going to use the following to solve. So 2/3 plus 1/6. So the first thing we're going to notice is we have a 3 here and a 6 here. So we don't have a common denominator, so we cannot add yet. Now the thing we're going to do is we're going to have to get to a common denominator. And something that you'll hear when we are adding or subtracting is you want to find the least common denominator. This can be known as the LCD, just abbreviated for the L, the C, and the D. All this really means is that we are going to look at the multiples of 3 and 6 and find the lowest one between the two and make that the new denominator that we want it to be. So let's look at some multiples of 3 first. So we have 3. So the first multiple of any number is going to be itself. And we're just going to add that number 3 to itself and get 3 plus 3, which is 6. 6 plus 3, which is 9. 9 plus 3, which is 12. 12 plus 3, which is 15, and so forth. Now let's look at 6. So now we have 6. So we have 6. 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24, and so forth. Now we're finding the least common denominator, or the least common multiple between these two, which will be our least common denominator. And this is going to be 6, because it's the common number that's shared between them that's the lowest in value. So what we want is for this 2/3 then to then have a denominator of 6 on the bottom. So that means the number is going to have to be multiplied by some fraction to get a new value. So we have 2/3. Now if we want to get to a common denominator of 6, so if we want to get 3 to 6, we just need to multiply it by 2. Now whatever we do to the bottom, we have to do to the top, so then it doesn't change the value of the number. This is the same value, but different numbers. So anytime you multiply a number by a fraction that is a number over the same number, it's just multiplying it by 1, which does not change it at all, right? It's essentially going 2/3 times 1. Then we're going to go ahead and add the 1, 6, and we can leave it because we want 6 to be our denominator. So it's good as it is. Then what we need to do is we need to multiply the top numbers together, and then we need to multiply it with the bottom numbers for the first fraction. So we get 2 times 2, which is equal to 4. 3 times 2, which is 6. Now, 4, 6 is the same value as 2/3, but we're just making it into a new denominator so we can add these two together. So then we go ahead and add, because we have 4, 6 plus 1, 6. So what we do is we add the top numbers together and we keep our denominator. That's really important to always keep our denominator. So this is 6, and then 4 plus 1, which is 5. So our answer is how many inches of snow was there in accumulation? Well, it would be 5, 6. And then this is reduced because we can't reduce this any further. So this is our solution. Now let's do another example. Example 3, add the following. We have 1/4 plus 3/7. So you can see we do not have the same denominator, so we're going to need to find it. So let's do some multiples of both the 4 and then the 7. So we have 4, which is then 4, 8, because we're just adding 4 to each one. 8 plus 4 is 12. 12 plus 4 is 16. Plus 4, which is 20. Plus 4, which is 24. Plus 4, which is 28. Plus 4, which is 32. And we can stop there and see if we can find a common multiple or our least common denominator between the two. So now 7. We have 7 plus 7, which is 14, plus 7, which is 21, plus 7, which is 28, plus 7, which is 35. Now remember, we can always do the multiplication for each one where you just increase the integer by 1 and multiply it by the number, like 7 times 1, 7 times 2, which would give us all these numbers. So you can do either method. This is the way I do it. And then I look for our least common denominator between the two. So we can see that we have a lot of numbers before we get to a common number. So our common number is going to be 28. So we can go ahead and look at this and go 1/4. So we're going to need to multiply both numbers by different fractions to get to a common denominator of 28. So this first one, we need to get to 28. So how many times does it take to get to 28? Well, you can see that this number, so we have 4, 8, 12, 16, 20, 24, 28. Well, 4 times 7 is 28. Well, if you aren't sure, just count the numbers we have. So we have 1, 2, 3, 4, 5, 6, 7. Because every time we go up, we're just increasing it by 1. So if we did 4 times the number to get to that number, which would be 7 here, so 4 times the number it takes, so 7, would equal that number. So what we're going to do is we're going to put 7 over 7, and then we're going to add. Then we have 3 7s. Then we're going to go ahead and multiply this number by a fraction to get to 28. So how many times does it take to get to 28? Well, we have 1, 2, 3, 4. So we're going to go ahead and multiply this fraction of 4 over 4. So essentially all we're doing is just changing the numbers so they have the same value but the same denominator now. So we go ahead and multiply the top numbers together, and then we're going to multiply the bottom numbers together. So 1 times 7 is 7, which 4 times 7 is 28, because that's the common denominator that we want, plus 3 times 4, which is 12, 7 times 4, which is 28, and then we can go ahead and add. So we keep our denominator, so that stays to 28, 7 plus 12, which is 19. We have 19 over 28 as our final answer because that is in its reduced form, or our lowest terms for that fraction.